So, on to our next presenter. This is item 10, tracking nutrient dynamics and habitat change, the role of participatory science in Florida's seagrass meadows. And I will now pass it, well, I have to do the intro. So, Carter, hold on one more second. So the purpose is to share initial results from a Charlotte County and University of Florida Sea Grant project to quantify and analyze algae samples collected through the Eyes on Seagrass Community Science Initiative from 2019 to 2023. And the CCNP connection is this relates to fish, wildlife, and habitat protection. Action 1, protect, monitor, and restore estuarine habitats, including seagrasses, as well as water quality improvement. Action 5, reduce harmful algal blooms. So now Carter can have the stage.
Should I share my screen to like hit the next slide or?
No, just tell us to advance. We got it up on ours. Can you see it okay?
Yeah, I can see it.
Perfect.
Okay. So thank you. My name is Carter Oleckna. I'm a PhD student at the University of Florida, and I am Brandon Moody's intern. And today I'm going to be presenting the role of participatory science in Florida's seagrass meadows by tracking nutrient dynamics and habitat change. Next slide. So who are we? Eyes on Seagrass is partnered with the University of Florida, the NOAA, and for our study region, Charlotte County. Next slide, please. So what is Eyes on Seagrass? Can you hit it again? Eyes on Seagrass is a citizen science program for the repeated monitoring of the distribution, abundance, and species composition of seagrass meadows. There are 10 Eyes on Seagrass monitoring programs throughout the state of Florida. Next slide, please. And today we're going to be discussing our Charlotte County study region. Next slide. So I want to start off by saying the Charlotte Harbor is a very unique system, and it's the second largest open water estuary behind Tampa Bay. There are two freshwater tidal inputs, the Mayac River and the Peace River, that deliver significant nutrient loads that influence the estuary's productivity and water quality. And the image on the right, we have our study regions grouped by color. In yellow, we have our upper and lower Lemon Bay. In pink, we have the tidal Mayaca. In the red, we have tidal Peace. In the blue, we have upper and lower west wall. And in the green, we have our upper, mid, and lower east wall. Next slide, please. So the Charlotte Harbor is a very important resource to Charlotte County because of the economic value. It's produced 863 million in economic benefits, 1.1 billion in recreational spending, 1.4 million in fishing product, and 864 million in property value. Next slide, please. And an example of this natural resource within the harbor is the seagrass ecosystem services provided by Seagrass in the harbor. Seagrass is responsible for providing habitat, food supply, improving the water quality. It's a carbon sink and stabilizing shorelines. Next slide, please. So how did we learn about the 2019 seagrass decline in Charlotte County? It was actually from local anglers and charter captains of the harbor. People were having a hard time finding seagrass beds. They weren't catching as many fish, and they kept getting caught up in the algae in the harbor. So they went to the local sea grant agent at the time and voiced their concerns that they need more seagrass and they're tired of this algae problem and they want to catch more fish. So this is what sparked the 2019 Eyes on Seagrass Monitoring Program in Charlotte County. Next slide, please. So now that we started in 2019, we have data through 2025. So we have 6 years of Eyes on Seagrass data, and I'm going to be discussing the objectives from this data. Next slide, please. One more time. So the first objective is to assess long-term trends in species composition in relation to historical disturbances. One more time. Our second objective is to compare citizen science data with data collected by state agencies to evaluate consistency and data quality. And one more. And the third objective is to use algae stable isotope signatures to infer temporal patterns in nutrient sources. Next slide. So our first objective is to assess long-term trends in species composition in relation to historical disturbances. Next slide. Okay. So these are the three dominant species in the harbor. We have turtle grass, shoal grass, and manatee grass. And this is how we describe our species composition to our volunteers. We compare fettuccine to thalassia, linguine to haliduli, and spaghetti to Sarengodium. And this kind of helps describe what these species will look like underwater and how to ID them. Next slide. So for the Eyes on Seagrass monitoring program in Charlotte County, the volunteers are sent out to a certain site and they have six quadrats within this site. And at each quadrat, they are to measure depth, sediment, algae density, seagrass species, blade height, and the epibiota at that quadrat. And so, can you hit the next slide? They start at the 0 meter mark, and this is closest to shore. And then hit it again, please. And they go to one more time the 10 meter mark, and take these same seven parameters, and then one more time, please. One more, yeah. So at the 20 meter mark, they are to grab a algae sample if it's available, and this is what we'll be using for our objective three, the algae stable isotope analysis. And then you can just keep hitting it to the next slide. They swim to the 30 meter mark, the 40 meter mark, and the 50 meter mark, taking these same seven parameters at each quadrat. So here's our first figure. We have our seagrass percent coverage from 2019 to 2025. On our y-axis, we have our seagrass percent coverage, and our x-axis, we have our year going from 2019 to 2025. And in blue, we have Haliduli radii, and orange, we have Syringodium filiforme, and in green, we have Thalassia testudium. And so you can see from 2019 to 2021, there was an increase in seagrass percent coverage, but then from 2021 to 2025, there was a decrease in seagrass percent coverage between all three species. And you hit the next slide. It's important to note between 2022 and 2023, we had a storm event, Hurricane Ian, that could have contributed to this die-off. Next slide. And there was three other storm disturbances between 2024 to 2025 that could have contributed to this die-off of seagrass. Next slide. So here we're looking at the same figure, except now we have macroalgae in light blue. And there's no clear trend with this macroalgae, but what we could see, if you remember, I said that the Eyes on Seagrass monitoring program started because of this macroalgae problem in 2019. And so from 2019 to 2022, there was a pretty significant increase in the amount of macroalgae within the harbor, which was not good. And then in 2022 to 2025, it follows the same pattern of a macroalgae die-off, similar to a seagrass die-off between 2022 to 2025. Next slide, please. And so here's a figure by Redmond et al. That kind of explains the storm disturbances and how they can impact seagrass. So in the left side of the image where the water is blue, the sediment's not mobile and the water is clear, so light can penetrate to the bottom and encourages seagrass growth. And as you move throughout the image, the sediment becomes more mobile, the water's more turbid, and the light can't penetrate to the bottom, and the seagrass can't thrive in this type of environment, which sediment mobility is caused by the storm disturbances that we discussed in the previous figure. Next slide, please. One more time. So this is a figure created by LaPointe. Is it frozen?
It looks good on the main screen. I don't know why it's frozen like that when we try to advance.
All right, there we go.
Oh, that's weird.
So on the left side, we have optimal light and optimal nutrients, and seagrass is plentiful. And then when nutrients starts to increase and the amount of light decreases, then we start to see macroalgae populations increasing, and algae outcompetes seagrass in their environment for light and eventually smothers out the seagrass until there is no more seagrass and it's just macroalgae on the benthic floor. Next slide, please. So here's some images from FWC in Charlotte County when they were doing their own surveys, and you can see in this picture there's just a lot of algae on the floor, and you don't see much, even any seagrass. And on the right image, when they're doing their fish trawls, their nets are just getting caught up with a bunch of algae. So algae is still a problem in the harbor right now. Next slide, please. So what we can take away from this objective is that disturbances may impact Charlotte Harbor, and Eyes on Seagrass helps track these changes to seagrass, and algae varies year to year, and more research can help better identify these trends. Next slide, please. So our second objective is to compare citizen science data with data collected by state agencies to evaluate consistency and data quality. Next slide. And so we're going to be comparing our Eyes on Seagrass citizen science program to our state agency, Charlotte Harbor Aquatic Preserve. And so here we have our 30 CHAP sites. On the y-axis, we have our seagrass species, and on the x-axis, we have our collector, either CHAP or EOS. And if you look at the key, if it's a white square, that means that the collector said the species is absent from that site. And if it's green, that means the collector said that the species is present. And so these are 30 CHAP sites that we sent our volunteers out to. And so this is a lot to take in. So if you hit the slide one more time, I kind of summarized it with this percent agreement. And so really you have three options. Either both collectors said the species is present, both collectors said the species is not present, or one collector said the species is present and the other collector said it was not present. So there's a 36% agreement on Haliduli, a 68% agreement with Sarangodium, and an 80% agreement with Thalassia at these 30 CHAP locations. Next slide. So what we can take away is that mean agreement varies by species, which can guide future training, and agreement varies by location, which could reflect habitat complexity and varying seagrass beds. I also want to note that the methods for the eyes on seagrass and the chaps for surveying seagrass is not the same, and we kind of try to account for this by we send our Eyes on Seagrass volunteers to the middle of the bed, and CHAP has a beginning, middle, and end. So we took the middle data and compared it to our Eyes on Seagrass monitoring data. And also the volunteers and the CHAP go out to these sites at different times. So that could also attribute to some of the differences in the percent agreement. We can go to the next slide, please. So our third objective is to use algae stable isotope signatures to infer temporal patterns in nutrient sources. And this is from when the volunteers grabbed the algae sample at the 20-meter mark during their surveys. Next slide, please. And so here we have the same image that we showed you earlier. We have our different regions of Charlotte County. And these algae samples were from 2022 and 2023. Next slide. So here we have our nitrogen stable isotopes by region. On our y-axis, we have our nitrogen stable isotopes, and on our x-axis, we have our regions within the county. And we have this red line set at 3, which represents an anthropogenic influence of nutrients. And what stands out is that both our tidal Mayaca and our tidal piece are significantly different than the rest of the regions in the harbor, which is not a surprise because we know that both of these freshwater inputs are responsible for delivering nutrients into the harbor. So we go to the next slide. And so here it's the same nitrogen stable isotopes, except we compared it to carbon stable isotopes. And so on our y-axis, we have our nitrogen stable isotopes, and our x-axis, we have our carbon stable isotopes. And so when we look at our nitrogen stable isotopes at the top, we have our tidal piece and our tidal Mayaca, which is the same as the previous figure I showed you that we know that both freshwater tidal influences are bringing nutrients into the harbor. But if we look at our x-axis, looking at the carbon isotope signatures, we can see that there's no clear trend, which we can contribute this to the species composition of the algae, the hydrology of the harbor, or light productivity within the harbor as well. You can go to the next slide. So what we can take away is that distinct regional isotope signatures across the harbor. Nitrogen variation may reflect nutrient inputs. Regions with higher nitrogen values, like the tidal MAC and piece, could be influenced by anthropogenic nitrogen sources like runoff or wastewater. And carbon differences indicate carbon source variability. And the spread in carbon values across regions may reflect differences in light availability, water flow, and algae species composition. Next slide. So here's the 3 objectives that we discussed today. We assessed long-term trends of species composition in relation to historical disturbances. We compared citizen science data with data collected by state agencies to evaluate consistency and data quality. And we used algae stable isotope signatures to infer temporal patterns in nutrient sources. Next slide. So overall, Eyes on Seagrass has been effective in providing long-term monitoring data, contributing to the field of knowledge for Charlotte Harbor, engaging the community, and informing practitioners of where to put their attention. Next slide. So if you want to learn more, here's our Eyes on Seagrass website. And then one more. And here is my email. I have a county email, but I don't log into it because it conflicts with my UFL email. So if you want to reach out, if you have any questions after the presentation, you can feel free to email me. And that's it. Thank you.
Thank you. Okay, I will open the room to questions for Carter. If everyone's, yeah. And we have about 5 minutes, so I could start off with one. Was there a specific species of algae you were collecting the nutrients on, or was it just whatever was collected at that 20-meter station, or 20 foot station, the middle station?
Yeah, so we are actually working on identifying the algae species right now, but when we did the carbon and nitrogen stable isotope analysis, it was just based on whatever species that the volunteers grabbed.
Okay.
Those green, reds, and browns.
Okay.
I just want to say, really nice job with your presentation, Carter. This is James Douglas. Nice to see a FGCU alumnus in all places. I thought it was interesting that there were both similarities and differences in that CHAP monitoring data versus the EOS monitoring data. You said they were taken at different times of the year, and that might be part of the reason. And I was going to offer that in Lee County, recent Lee County expansion of the EOS program, we did it at the same time as the FDEP transect station. So maybe that would be an opportunity to see if, when they're done at the same time, if there's a better agreement between them, or if it's still kind of a training identification thing that we need to work on. So,
can I? Oh, sorry, Carter. Go ahead.
No, I was just saying that would be an interesting finding. Go ahead, Kate.
I was gonna say, James, it was all the same effort, actually. I think so. Some of that Lee County data from the Colusa Waterkeepers was in this analysis as well. We did it at the same time up in Charlotte County. There's about maybe like a 2-week delay. But it's just not at exactly the same time. But I think it's all in within a month or so.
Oh yeah, okay. Well, I expect that's probably not a time difference then. It's people difference.
Yeah. Volunteers.
Yeah, and I will say in defense of that, I think it was telling that the Haladuli was the species that there was the most difference in, and especially depending on where you were, like in the Upper Harbor area, we've lost just so much seagrass in this last year that we were out. I'm impressed by your data entry and turnaround, so congratulations, because I'm impressed because we're still doing our data entry and QA for ours for 2025. But we were seeing some comebacks in species, but since we're on a fixed transect, we're seeing what we see there, and I think it does capture a lot of what the overall health of the bed does. But since the volunteers are kind of they're like in a different area, they might be capturing things that maybe just in our transect we don't.
Right. So a spatial difference too.
Yeah.
Aren't the CHAP or DEP transects longer with more space between stations?
It's just asking a different question. So we're looking at deep edge and like the extent of the bed.
So James, and I might be able to provide some insight. Ariel was kind enough to provide basically a middle point for her transects, which cover the whole bed. We didn't feel like we could ask volunteers to do that since some of those beds are like 200 to 600 meters, right, Ariel? Like crazy.
Yeah, the ones in the harbor are 600 to 700 meters long. So. Yeah.
And so basically what we tried to do is get the volunteers as close as possible to that middle point. We didn't tell them that they had to look for the exact fixed transects. We were just trying to get sort of a base level on is this data mostly the same? That's why we did presence absence as well, rather than more specific numbers.
I was just going to add really quickly too, and I know I mentioned this during your presentation at Surf Carter. We really appreciate that this is an additional source of data collection. We see it as supplemental to ongoing, data collection. As Ariel mentioned, we're asking different questions with the different data sets, and we will be pulling the eyes on seagrass related to the algae information, into to be available on the Water Atlas when, working with Kate and everyone when that's ready to, so it can be useful to all of you potentially when you're doing future analyses and looking at the area. So, thank you.